to invite Omer to start talking about compliance in Kubernetes. So Omer, the stage is all yours.
All right, thanks, Julio. All right, great. So we have a lot to cover. Right.
Just small comments, Omer. Guys, if you want to ask questions, please feel free to write your comments in the IM, in the chat of the Zoom. We will have time in the end of the lecture. We will have time to questions for Omer. And if we won't have time, so we will keep time till the end of the meetup, of course, to ask questions. So please write your questions and I will read them in the end of each and every lecture. Sorry, Omer, the stage now is all yours.
It's all right. All right, great. So we have a lot to cover for the first session. We're going to talk about a little bit about GRSee, what we are and what we do. Then we'll set some basic terminology, so people who are not familiarized with Kubernetes can also gain some of the insight in this presentation. Then we'll breeze through the PCI requirements in a high-level overview, and then we'll cover the main challenges of the PCI in the container, in a container environment. Of course, these are not the only things that you will encounter, but these are probably the harder part of the certification. And we'll finish with the easier solutions that come pre-built into Kubernetes. And that's the agenda for this session so far. All right, so a couple of words about me, who I am. Omer Donin, CTO in GRSee, previously pen tester and consultant. I solve compliance and design flows by the day, and I like short introduction. So let's continue. Right, GRSee was established in 2009. We operate from the East Coast, West Coast in Israel. We have around 250 clients, 50 employees. We are the first GRSee company to certify a fully AWS hosted environment to PCI level 1. As you can see here, these are the sum of the services that we provide. In a general sense, PCI compliance, from compliance, PCI user management, SOC 2, application security, cloud infra security, risk management, security as a business enabler, and cyber resilience. Like I said, I'm reading through the introduction to get into the actual content because we have quite a lot to cover, sorry. All right, so PCI, why do you need it? First of all, in a general sense, if you're not familiar with PCI, let's start with what would happen without PCI, right? So without PCI, you might find the business under fines or sanctions from clearing companies, right? These sanctions can also appear as blocking their ability to charge credit cards or any kind of other incapabilities that you might be liable to. So if you're going to use credit card within your company, you want to be PCI compliant. As we've seen a couple of slides, PCI has specific instructions on what should be done in a system that holds credit card data. Now, containers make things a bit complicated to some degree when you try to understand which assets are in scope for the PCI compliance, because everything is dynamic in this environment, so machines are turned off and on anywhere within the network, and the PCI weights on the machine compliance makes things very much harder to run. So in this session, we will cover the main challenges that containers need to comply with under the PCI scope. All right, so like I said, we'll start with some terminology to make sure that we have a baseline of definitions so everyone can understand the insight for this session. All right, so it's a one-liner description. I try to make sure that everything is well phrased. So a container, right? So that's the smaller box here. Container is a process or a program, basically, right? It runs a service of some kind. It's not too different from your standard Apache service installation, apart from one main difference, which is that a container works within its own virtual environment, segmented from other resources on the computer that runs it. Well, except from what you specifically share with it. So it's very much like a local virtual machine that holds only what it needs to run the service that it is intended to run. So that is a container. In a general sense, if you're not familiar with it, it's a small, a minimized virtual machine. Pod is a group of containers, right? So that group can contain one or more containers, and these containers within the group share a resource. Either it's a pod, they share a resource either from network perspective or resources from other assets within the network. In a general sense, a pod would always run on a node. Now, a node and host, these two terms are kind of combined together. A node is a reference to a hosting machine. All right, so that hosting machine can be virtual or physical, and each node is managed remotely by the orchestration system, the master. A node can hold multiple pods, and how it does that is based on the instruction the master gives to the node. So in a general sense, to make things a bit more clear, imagine having several servers with different hardware, and the capabilities of each server is different. So the master's job is to distribute the workloads in a balanced way that utilizes the best capabilities of each server. The part in the server that loads the pod, right, the group of containers, the virtual machines, right? So the part in the server that loads the pod is called a node, right? So the node is the part that loads virtual machines, and the server by itself, that's basically the hosting machine. Orchestration system is the master, right? It's the framework that connects and manages several nodes to work as one unit, right? The commands in the orchestration system are often referred to as infrastructure as code, and Kubernetes is the most popular orchestration system, and that's why most of the talk today we're going to focus about Kubernetes terminology, as you've already seen that I'm already oriented to. All right, so that's about the terminology. Now let's talk a little bit about the differences between Kubernetes and cloud and on-prem servers, so that when we go into the PCI requirements, you understand better, you have a better understanding into why the container environment poses not such a problematic issue, but difficult challenges on the PCI environment, or on being compliant with PCI requirements, sorry. Right, so the differences between Kubernetes and cloud and or on-prem servers or services, right, is that cloud and on-prem devices are acting as appliances or virtual appliances that enable network control on the relevant layer. In other words, they are all acting like the legacy devices that you are all familiar with, right, like routers, switches, firewall, etc. Orchestration technology does not play well with this approach, as you could make a strict firewall rule due to the dynamic orientation of assets in the environment. It is often misaligned with the security needs and limits the required flexibility from the system. So, since orchestrating environments are managed via code, it is only makes sense that the segmentation within the environment would also be applied using code, and that would allow the flexibility to be maintained. Now, infrastructure as code, this item is relevant basically to any dynamic environment that its infrastructure is managed by code. Since the code is dynamic, you need to have certain controls to make sure that the commands are running as planned and the applied configuration is secure. Let's take an example to make sure that the point here is clear. Commands that embeds parameters with values which were originated from untrusted sources, let's say client side, right? These parameters here, these parameters could be used to expand the commands into additional instruction for the infrastructure. Alternatively, another way where infrastructure as code may go wrong, which is, by the way, also basically relevant to any kind of IT practices, is standard misconfiguration, right? For example, overly delegating a user or allowing permissive access to a service account. The same way that standard code has weaknesses, like known PHP vulnerabilities, the technology behind infrastructure as code also have known vulnerabilities. But this one is more focused on configuration, and dynamic configuration leaves more attack surface to abuse. So these are the main challenges that you will be facing when you try to implement PCI within container environments. Now, from that perspective, let's move on to the next section, which is what are the PCI requirements and why and how do these pose challenges to the container environment, right? So what we have here is a high-level overview of the PCI requirements. The PCI has many requirements, and unlike some other regulations, and standard PCI goes very well into specifics on how and when and what should be done in the PCI environment. The requirements are divided into 12 chapters, and each chapter has a detailed specification drilled into tasks. Now let's quickly read through the list, and then we'll dive into solving these these in orchestrated environment. But again, just to be clear, this is a high-level overview. For example, the first requirement here is to install and maintain a firewall. But what does it really mean? Install and maintain a firewall? Do you need to micro-segment the environment? Do you need to update the firewall version? Do you need to periodically check your rule set? And if so, like how often do you need to do that? So each topic in this list has a specific task drilled into it, and this is a high-level list, right? So on the next slide, you'll see that the high-level list is drilled down into the actual tasks that are being required of you, and then how would you approach it within the container environment. Right, so what we have here is, first, like I said, install and maintain a firewall rule, do not use vendor supplier default configuration, protect stored cardholder data, encrypt transmission of cardholder data, use and regularly update antivirus software or programs, develop and maintain secure systems and application, restrict access to cardholder data, assign unique ID to each person with computer access, restrict physical access to cardholder data, track and monitor all access to network resources, regularly test security systems and processes, and maintain policy that addresses information security. So these are the high-level PCI requirements. In general sense, the headlines that you need to comply with, right? Now, each of these is drilled down into actual tasks. Now, from this list, we're going to focus on the main challenges, the main tasks that are proving as a PCI challenges for Kubernetes front. So we're going to overlook this list and dig deeper for each item here. So for the firewall part, we're going to talk about network segmentation and host isolation. To protect cardholder data, we're going to talk about AV scanning and monitoring. Vendor supply defaults, we're going to talk about hardening, maintaining secure systems. We're going to talk about vulnerability management program, and restrict access to cardholder data. We're going to talk about strong access control. All right, so far that was the intro. So among the toughest challenges within setting a PCI environment is the network segmentation part, right? The main issue here is that the fact that containers can communicate both inside the same node or between nodes, by default, there are no limitation. This is done basically from the Kubernetes perspective for several reasons, but the main one is to allow keeping the environment dynamic, because just imagine having several networks running up and down with DHCP in it, so IP provisioning is all over the place. Managing a firewall for that would be crazy. So this is our PCI pod, right? It's from now on, this will be our PCI environment. So that means that this pod holds services that are exposed, process, and transmit credit card details. Okay, so we're going to mark it in red. Now, that being red, that means that the hosting server, right, the node that this pod is running on right now, also need to comply with PCI requirements. So we're going to color that red as well. Now, that makes that other pod that was showing the node within that host to be a non-compliant pod, right? It's a general service pod, but it takes place from a PCI compliant host, and according to that, that pod needs to be compliant with PCI requirements. While basically there is no need for that pod to be compliant, but just from showing that host resources, it will be added for additional weight and legislation. Let's call it like that. Right, the requirement will be there. All right, so, but as we know, orchestrated environments are dynamic and flexible. So that means that pod can be used within different hosts. So if we run a pod on this host, it might as well be running on any other host. So if our PCI pod is getting too familiar with other hosts, it will include them within the PCI compliant as well. And this just expand the list of assets that we need to work and put work into and put our effort into making sure that all of these assets are compliant, right? So in order to avoid all this extra work, what we need to do is basically we want to set up tagging, okay? So to avoid that, to avoid the spread around of the PCI compliant assets list, what we want to do is by tagging the node as the only host that can run PCI pod and tagging the PCI pod accordingly, for example, marking it with PCI allowed tag on them, we can create designated pods that allow only PCI pods on them. Now, node selector is a field of pod spec that requires that works in a key value pair, right? Where the node that doesn't have the right label would not be able to load on a pod that is that belongs to PCI assets, right? So if we created a little bit of a demonstration here, right? So a PCI tag pods would not be able to load into any other node except for the one that is tagged, right? So basically, it's very straightforward. It's tagged as PCI allowed, so then it's it is allowed to be implemented into PCI nodes only. So how does all of that relate to network segmentation? Well, Kubernetes by default set up a virtual network and accordingly set an IP address for pods, which is dynamically distributed by default, right? So pods of the same deployments, either on the same host or between nodes, can communicate with each other. So to implement the segmentation on these layers, you would need a third-party security control like Calico, Cilium, Core, or GRSee, etc. There is a full list on the Kubernetes documentation. Now, these services will implement network security, allowing segmentation within your cluster, okay? Now, also, you could use service meshing solutions for the segmentation part, but so far, these solutions are coming with a bit of a baggage because they have, in some cases, they have certain limitations. For example, they provide you with some features like TLS everywhere, or better control, or low collection, etc. But they all come with additional baggage that require heavy implementation during installation, right? So choose wisely. Basically, if all you need, and in most cases, that's what you need from PCI perspective. If all you need is network segmentation, it's probably not for you. Pick one of the simpler solutions, which provide you straightforward network segmentation. Now, some cloud-native firewalls are focused on self-learning concepts, but the line between learning what to block and actually blocking within these systems is not well defined yet. So you might want to consider using these tools to learn about the networking within the system, but not to do the network segregation itself. So in summary, with tagging, you can control the host. With third-party solutions, you can implement segmentation. Now, one last note, important note on this matter before we move on. As a customer, you can define, or as a customer for for certification, right? Not as a customer for anything else. They're just as a customer for they want to certify a certain environment within your network, right? You can define that everything in the Kubernetes deployment falls into PCI scope, right? So basically, you can avoid segmentation completely if you just include everything into the PCI scope. Obviously, as a byproduct, this would include other services, not related services, if you have any, on your Kubernetes environment, to be included as well into the PCI scope. But in some cases, that could serve as a quick win or for a hard challenge. So that's something that you should be aware of. All right, next topic. Protect cardholder data via AV and scanning. Right, so antivirus standards behavior is to lock files away, right? Or lock files while it is being investigated. Now, since container images often holds only the crucial files it needs to run, omitting anything in the environment or locking any files will probably cause the image to hang. So that is a problem. So that is a problem actually, right? Basically, right, any image that hangs in production environment is a problem. And the documentation that we see here is copy-pasted from the Kubernetes site. And they basically say it's straightforward. When an antivirus software scans files used by Docker, these files may be locked in a way that causes Docker commands to hang. One way to reduce this problem is to add Docker data directory, then specific operating system settings. So I'm jumping that. To the antivirus exclusion list. However, this comes with a trade-off that viruses or malware in the same Docker image, in the Docker image, writable error in containers or volume not detected. In other words, if you do choose to set up your antivirus to scan this data, you could exclude certain parts of the storage to make sure that the Docker environment is still safe. But these services, operating system services, or generally services backbone files, are often being targeted by viruses. And when viruses try to access a network, it would often try and grab hold of the of a standard file. So if you put any of these into the exclusion list, you're basically making that available to the virus to run at. So, and also one last note here, the last line on the documentation says, it suggests that stopping a container, scanning it, and then resuming it. Now, doing so on production could make other services to hang, and accordingly, depending procedures would also hang, and then everything breaks. So you probably want to avoid that at all. Okay, so so instead of AV scanning, what can you do? Okay, so in a high level, detect anomalies and verify the base image is secure. And also be quick at dropping and spawning new machines. So this way you use the flexibility of an orchestrated system to benefit security. Okay, so the anomaly detection is meant to identify any non-standard behavior on the container and quickly mark them down for respawn. This way you are not leaving much time for a malware to act on its own in a compromised system. When you spawn a new machine, you don't have to worry about malware since you need to have full confidence in your baseline image. Now, this leads us to the next item, which is how to gain full confidence in your images. So, how do you gain confidence in baseline images? To thoroughly secure your baseline images, you need to build most of it from zero. Trust only formal repositories, and after you have working image, scan the baseline images on every change and test it periodically. This is done so you can gain full trust in these images. These images are going to run as your baseline services, and they are so you want to make sure that they're secure and uncompromised, because you will basically rerun them on every cycle that you have. This in turn creates another task of verifying that the base images were not tampered with or switched by an unauthorized actor. So you want to run integrity monitoring and verify that the hashes of the images are, you want to verify the hashes of the images before you start processing them. Now, as for static scans should run during the image building phase, as it acts out as the final step before committing an image to use in production. This is also a good time to note that access control to the image repository should be strictly limited. This is one of those settings that you want to run periodic checks to make sure that no one is tampered with it. And only a handful of people can edit the repository settings. Most scanning tools these days are open source, so your static scans should cover the layers of an operating system, service application, frameworks, third-party open sources, etc. So on each of these layers, the scanner should identify security gaps within it, like older version or permissive configuration, etc. Basically, you know how a scanner works, so I'm not going to delve into that. But in a general sense, these are the layers that should be covered by a scanner. As for hardening, hardening is one of the key factors to creating a secure baseline image for a service. As I said in the previous slides, you want to trust your baseline images. So hold no punches back when you test the baseline image. This is one of the core services that you will run on every cycle, so the impact on security could be great or devastating. Hardening often comes in 3 layers: operating system, service, and appliance and application. And for each layer, you can have a default hardening or custom hardening applied. And Kubernetes hardening is no different. It relates to the host and operating system layers and the interaction with other assets, as well as the internal configuration. Kubernetes offers 2 main hardening features, which is security context and security policy. The security context configure pods and containers at runtime. The security contexts are defined as part of the pod and container specification in the pod manifest and represent parameters as the container runtime. Security policies are the control plane mechanism that enforces specific settings in the security context, as well as other parameters outside the security context. So you can think of it as security context is very granular permission oriented, and security policy is a bit more high view oriented. Anyway, in most cases you would use both. Now also take note here that Windows-based operating systems do not work well with security context, so don't rely on that for Windows-oriented operating systems. All right. The security policy provides us with 3 definitions of hardening that can be applied to pods, which are privileged, baseline, and restricted. These are applied via pod security profile, and each definition holds a spectrum of permissions and configuration by default, and you should adjust it to your application needs. In a general sense, privileged means that the pod is designated for application that would need elevated permission to run properly. Baseline or default is designated for medium risk or non-critical application, or in other words, application that won't need anything special to run. And restricted means heavily restricted policy, right? Following current pod hardening best practices. So if you think about it, restricted is the most secure policy to assign it to the front end when you can, of course. Privileged is the most permissive setting, so assign it to the least. And baseline prevents non-privileged escalation, so it should be good for backbone services. Now, some cloud services can provide you with the pre-secured images that are already hardened and marked for PCI compliant. These are good for you, and you can save a lot of trouble during the hardening phase by using this. So, but also note here that the hardening is not customized to your needs. And if you do go on and improve the hardening or customize it, the cloud provider would not be responsible for any of the images you created or changed. So it might break things. So that's also a point for consideration. All right, so far, this was the easier, the harder solution, right? All right, there you go. Right, so now for the easy part, right? We talked about the how to implement challenges. Now let's focus on the easier part, the solutions that are pre-built into Kubernetes. So first of all, let's focus on authorization and authentication. Actually, it's not much of an issue as Kubernetes API provides role-based access control, so the authorization side is covered. As for authentication, Kubernetes also supports a lot of authentication methods, and one of them is OpenID. That is basically OAuth 2 that will probably require the least amount of headache from you, so you can embed it with any third-party services that supports OpenID for authentication, like Google or Amazon or anything like that. So these are easy solutions, easy peasy lemon squeezy on that part. Right. From a vulnerability management point of view, the only thing that we need to state here on this subject is that embedding the scanners, either static or dynamic, into the pipeline will allow for a quicker feedback, so that developers can be introduced as quickly as possible to any new vulnerabilities they introduce with the new build. It is a very common practice these days, but most open sources support this type of integration. And yet I don't see it anywhere, so it should be mentioned, right? It should be said. Provide the developers the feedback from QA that includes the results of the security vulnerability scanners. Yeah, that should be included without a doubt. Right, and the last but not least, as for auditing, Kubernetes provide an interface where you can turn on the auditing, and it will show you exactly what was changed and by whom and when. So that front is easy peasy lemon squeezy again. All right. So that is basically a very quick run on the main challenges that you have while implementing PCI environment within Kubernetes. And if we got some time, then I can answer some questions. Let's see here.
Yes, thank you, Omer. Guys, please feel free to ask questions to Omer in the chat. So let's start with couple. Sahil, I hope I'm pronouncing the name correctly, is asking how are we expected to respond to the anomalies which don't have signature predefined within a detected engine, maybe a 0-day?
All right, so it's a great question. The main concept that you should be thinking of that in an environment that runs the same process a zillion times a day, anything that is outside of that process can be considered an anomaly, because all of your machines basically have a predetermined route that they should be operating in, and anything outside that route, considering networking, network communication, and basic process behavior, right? Like accessing files, accessing network storages, privilege escalating, or basically any kind of executables that are running outside of your standard route is an anomaly, right? So you want to have kind of two stages for that. Stage one, you want to learn your environment in a sterile, you want to learn your behavior in a sterile environment. And then after you got that, anything that runs except for that, outside of that, is an anomaly. You want to drill down, you want to understand what's going on in there.
Okay.
All right. Yeah.
Thank you.
I think that
another question from Timo. Is it worth to scan for vulnerabilities in a package images, just on the packages layer, not the application dependencies? And have you ever done something else than accepting a vulnerability until a patch is there?
Right. First of all, I'm going to answer the second question first, because I'm going to have to reread the first one. Every vulnerability, unrelated to any of what we're talking about, that any vulnerability could have several solutions, right? A patch is one of them. It's not the only solution. You can always find or redefine a way to exploit something, but a hardened system would make any kind of attack to be harder to achieve. So in other words, vulnerability is in most cases trying to target a specific aspect or a specific behavior of a system, and you can just harden around it, right? For example, right? Let's just make an example to be easier. Let's say that your internet shop has no input validation for a certain parameter, okay? You could change the code, right? So that's a very strict approach. There is a parameter is missing an input validation, go on and change the code. And let's say the parameter is the price, okay? So that means that the price is coming in from the user has changed it from $500 to $5, and then it went on to the rest of your business. Now, the vulnerability itself would allow the user to change the price, but the rest of your company is working with a false price. So you could also just change a policy or create a policy for, let's say, the warehouse. Guys, before you submit a delivery, check the price, right? Like, make sure that it makes sense. And this way you can basically accept the vulnerability and make sure that you have a mitigating approach, right? Fixing other parts of your environment. Now, this is an example just to describe to you how a different solution or a different approach can solve a vulnerability without actually solving the vulnerability, right? Without actually doing anything to the code. But it's basically any vulnerability can be approached with direct approach, which is strictly the patch. But then again, to run an attack, you have a lot of dependencies that you need to go through, right? Like user permission, user hardening, server services, sorry, current services, or any kind of other security controls that run on that server. Right, so that's the first question. The second question, the first question, is it worth to scan for vulnerabilities in packages in images where just on a package layer? I'm guessing that what you mean here is that you run the vulnerability scanner based on the version of the package and not the actual, not the application dependencies. So you mean
think
that,
here, Omer,
yeah?
I think here the question was if you are scanning the image level or the image scanning that you are performing, is it something that is adequate and you don't need to scan the application layer, or in your thought you need to scan both?
Right, yeah. So basically it goes back to what pipeline you're in. If what you're submitting to the environment is a new image, so then yeah, you definitely need to scan the image. But if what you're submitting is a new application or a new application code, then you can probably skip that that stage because it's not an input that is required. Does that make sense?
Hope it is. Actually, I think it's also a method of depends in layers or secured in layer. So yes, application is one hand and image is another infrastructure that need to be scanned and of course secured accordingly.